we're team 8, whatever and why not, and this is our MP1 for the course CS511, and for that we have chosen the tool MongoDB. Um, First of all, I would like to introduce what is MongoDB. So it's basically a NoSQL database, and it's a document-oriented database. So in contrast to the relational databases, which is made up of rows and columns, it is built on the architecture of collections and document. The document here comprises of key value pairs, which is basically the unit of data in MongoDB. And the collection, it contains sets of document and functions. So it basically deals with documents and collections. Apart from that, it also has some cool features, like it supports dynamic schema design, so it doesn't have to conform to a strict schema, and also has automatic sharding. For data, it uses BASON, which is like binary representation of JSON like objects. Now, here we go to some statistics. This is the popularity of databases in April 2016. Here you can see MongoDB is at 4, and all the preceding 3 are relational databases. So basically, it's the number 1 popular database for NoSQL databases. The question comes, why MongoDB? Why is it so popular? There are a couple of reasons for it. One is the inbuilt functionalities that MongoDB database offers. Here you can see it has text search, geospatial queries, aggregation queries, map reduce functions. All those are inbuilt functionalities, which actually makes the use of MongoDB very easy. The other thing is the architecture on which MongoDB is built. It's a combination of relational and NoSQL. It offers the best of both, as you can see here. Uh, Again, to be specific, it has an expressive query language and indexing. It has strong consistency, which is rare for NoSQL databases. Again, it is flexible because it doesn't have a rigid schema, and it's scalable. It can support up to 1,000,000 operations per second, and it performs very good with even petabytes of data.
So I'll start with the installation and configuration setup. These are the steps that we are going to follow here, and I'll go ahead to the terminal and start doing them. So I'm going to clone it from the GitHub repository first using this, and it's done. I'm going to change into the working directory, and here I am. Now I'm going to run the script for installing. This is going to do 3 things. It's going to install the MongoDB and set the service up and running and import the JSON file. Here I'm using the restaurants JSON file. Okay, now it's done. Now I'm going to check if the service is up and running using the Mongo, and yes it is. So now I'm going to go to the working database using the command use CS511, which is our database, and I switch to it, and here I'm gonna go and see the first record of our restaurants collection, which is find one. Okay, so this is the structure of our restaurants collection, and this is the address, the building longitude, latitude, coordinates, street, and zip code, and the place where it is, which is Bronx, and the type of cuisine, bakery or American, and the grades which are following this particular schema here, and the name of the restaurant and the restaurant ID.
Okay, now I will introduce the basic functions in MongoDB. The MongoDB query is similar to SQL's. So when we want to insert or update, we can just use insert and update function. But for MongoDB, we need to specify which collection we are using. So we need to write db.collection name here and insert. And for update, when we use set and onset, we just update the attributes here. But if we use the update without set or onset, it will replace the whole content with a new one. And we also can rename the attributes in MongoDB with update function as well. About find function, we can find function with different field. And when we set the attributes as 1, we can get the result with the get the result which only include these attributes. And as for comparison operator in MongoDB, we have GT, LT, LTE, this kind of comparison operator. And we also can use MongoDB to have the iterate function. So we can use for each to iterate this print function. And we have other basic function in MongoDB as well, like distinct and remove. And also we can do for loop in MongoDB. And we have other operators like or, and, exist, and in. And for our machine problem, we will based on latitude and longitude data and try to find specific sets of restaurants in different areas. As for this problem, we will run MapReduce and geospatial queries on MongoDB.
I'm going to introduce MapReduce functions and the geospatial queries. For MapReduce function, MongoDB has a while support on it. So you just do db.collectionName, then .MapReduce, and you provide a map function and reduce function and options. So you can do out options allows you to rename the output collection, and you can also do query and sort and limit on it. For geospatial query, it's doing geospatial operations on 2D or 2D sphere object. So a 2D object is a point on 2D plane, while 2D sphere object is different types on a sphere. Well, the type can be point, line, polygon, multi-point, multi-line, and multi-polygon. And you need to provide coordinates to match the type. To define a 2D object, you just need a list with longitude, then latitude. And for 2D sphere, you will need a type and a coordinates. So for operations, geointersect and a geosphere only works on the 2D sphere. And for geowithin, you're going to draw a shape, and it will return the match coordinates in the shape. I'll show you how to use the geowithin with MapReduce later. Okay, here's our example. We're going to find top 10 restaurants within 1 mile radius of Morris Park Bake Shop, sorted by total score. So I'll do it in 3 steps. I'll show you how to do it. So I prepared it in the text editor. And first, we're going to find the coordinates of Morris Park Bake Shop. And here's it. Then we're going to prepare the map function and reduce function. And here it is. I'm going to just do copy and paste. I have this file ready in the GitHub. So for here, I'll try to find all. I'll draw a circle with its center at Morris Park Bake Shop, and give it a radius of 0.015, which is equivalent to 1 mile. Okay, let's do it. And here it goes. And the result will be input into this collection. And we can see it. Yeah, here it is. And then we do the query on the result collection, and I want to sort the total score in descending order and have a limit of 10. And here we go. We have the top 10. And here's some more features. So you can go to the links we provided. And for more information on basic query MapReduce geospatial queries, here's our 3 links. And thanks for your watching.